Bonjour tout le monde. Welcome to Vo. I just heard this is the way we pronounce Vo in English. That's pretty impressive. It was a nice talk. Thank you very much. So I don't have any movie. So I will be talking for 40 minutes or 45 minutes, probably less because there is a coffee break coming. By the way, there are seats available in the first row for those standing up there. What I'm going to do here, obviously, is not to tell you whether ChatGPT 45 is better than ChatGPT 23 or whether DeepSeek 2 is going to be better than DeepSeek 1. I think this is not the goal. The goal, hopefully, is to really make you question some of the beliefs you might have about AI in general. So a couple of words about myself. We have a very big computer science department here at EPFL. I am the oldest professor in that department. So I have been seeing the department growing from Badou, President Badou, and then Evi Cher, and then Vetterli, and then now Anna von Kuberta. It's a pretty cool department. If you still want to study, you should consider going there or send your kids there. It's a nice department. So before going to coming to Vaud, I was in France, and then I also spent some time in the US, but Vaud definitely is the best area to live and invest. Okay. These are the three questions I'm going to address. And I'm not going to give you any mathematical formula. There might be a couple, but that's not the goal. Is really share with you some perspective about this field. What is AI? I will share with you some definition that I believe is important to have in mind these days. Why now? What has happened in the last decade such that we can see these impressive prowesses of AI? And then what now? You are an engineer or you have a company or you're running an administration. What should you do? Obviously, I have no clue what we should do. But we have been talking about this, thinking about this, and I would like to share with you some ideas. So what I'm going to say here is going to be very simple. As I said, no mathematical formulas. There is this theory that says if you keep repeating to your audience that something is simple, they understand it. There is a pressure in the brain. Oh, it's simple. Then I should focus and I will be able to understand. So it's going to be extremely simple. So what is AI? Of course, you might wonder, come on, we didn't wake up and come to the Swiss Convention Center to hear yet another definition of AI. I agree with you. This might look very boring, but let me still come back to the very notion so that we are on the same page. In the 8th century, people didn't know how to do additions. More specifically, there were very, very few people who knew how to do sums and additions. The vast majority of people didn't know how to do it. Any clue why? Why? Exactly. Because people used the Roman symbols to write numbers. So imagine you have two big numbers written X, V, I, V, X, whatever, and then another one. How on earth would you add them? It's a nightmare. You really required very, very specialized mathematicians to do that. And this was considered really an obstacle to development. Not doing addition was a very bad thing for commerce. And there were two capitals of science in the world. There were Constantinople and Baghdad. And they were really trying to fight who's going to be the best one. And the one caliph in Baghdad, caliph who became caliph after the caliph, actually killed his brother. But that's true. So his name is not good. I think he was very good because he was promoting science and investing in science. So he asked his followers, hey guys, you paid a lot of money. Can't you find a way to make everybody be able to do addition? And this was a challenge. And one smart guy says, we need to change what we would call today the data representation. If we want to do addition, we should change the data representation. And if we do that, then we will have an automatic process. So the guy we're talking about used to translate Indian books into Arabic. That was the language of Baghdad. And he knew about those symbols. 1, because there's one angle, 2, because there are 2 angles, 3. And he said, oh, this is the data representation I should be using. And then I need a 0. And he invented the 0 because I need the 0 for this. And then he invented what we know today as the process of addition. And today it looks to us obvious. Is it simple? Enough? Are we together? Good. Thanks. What's the name of this guy who invented this data representation and therefore the automatic process that will enable us to do addition? How do we call these processes to do addition, multiplication, search? Algorithm. The guy was named Algorithm. And he wrote a book with processes to do addition, multiplication, résolution d'une équation du second degré, what have you, all kinds of stuff. And his take was, with the right data representation, follow me please, even the dummiest of us will be able to do mathematics. How? Because they don't need to think about it. They just apply the process. And in those days, those were called automatic processes. They were not called algorithms. Today, they're called algorithms because people refer to algorithmy to say, oh, that's an algorithm. Okay? So what he did was provide an average human being with the ability to do something that only mathematicians were considered able to be doing. And that was called AI in the 8th century. AI was the ability of a normal human to pretend to look like a hardcore big mathematician. 8th century. So there was this imitation game already there. Then few years passed. Interestingly, civilization moved to more Western Europe, but those books actually also got translated into Latin and other languages. And there was a French mathematician and engineer who was observing his father every evening doing additions and operations like that. And his father was accountable at the court of, I don't know which king of France, maybe one of the Louis or Francois or whatever. So he was working for him and doing addition every evening. He was applying the algorithm of algorithmy, but still he was spending his evening doing the repetitive process. So this guy said, this looks so repetitive, then maybe a machine would be able to do it. So he said, I'm going to build a machine and give it to my father so that instead of him doing the addition, the machine will do. And he built the machine. Any clue what's the name of the guy? Thank you. Blaise Pascal constructed a machine where he hardwired the process of algorithmic to do additions. So he gave the machine to his father, it worked, magic, and then other people came and said, this is impressive. Now, it worked very well. People started asking Blaise Pascal to build machines and so that they could buy them. But the church of those days, we're talking about the 17th century, decided to burn all the machines. And the argument was, this is the act of devil. Only the human should be able to do addition. This is artificial intelligence. Vade retro Satanas. We burn all the machines. And they did burn all the machines. But we were talking about a different now notion of AI. It became the ability of a machine to solve a problem that only humans thought they could solve. Okay, but we are still with this imitation notion. And people were talking about AI. Are we still together? Few years later, another guy, Leibniz, if you remember your physics classes, who wanted to compete with Pascal, built a machine that was doing multiplication. Says multiplication is more complicated than addition. My machine does multiplication. Again, he applied an algorithm of Khwarizmi, which he hardwired in the machine. Centuries passed, and then people said, okay, this is indeed AI, but, this AI is very specialized. The machine of Pascal does only addition. The machine of Leibniz does only multiplication. And there were few specialized machines. Then people said, actually, human beings are much more flexible. A kid can learn addition and the same day multiplication and can do both. whereas the machine of Pascal cannot do both, can do only one thing. Okay? So it took several centuries, and people were convinced that this ability to learn new algorithms and execute them is something that we will never put into machines. Okay? Machines had to be specialized. And it took another genius, Alan Turing, 1936, to say, but wait. What is really an algorithm, the addition algorithm? It could be represented again as a sequence of numbers. We could give the machine the algorithm as an input. Instead of giving the machine only the two numbers to add or to multiply, we can give the algorithm the numbers representing the algorithm itself to the machine. The machine will digest it and then will execute it. Okay? So what he invented was called the universal machine, in the sense that it is universal. It could digest every algorithm and execute it. Are we together? I'm not going to go into the details of the machine, but it is, in my opinion, the most important invention of humankind. Of course, I'm a computer scientist. That's my perception of the world. But I do believe this is an amazing invention. For those of you who didn't see the movie The Imitation Game, please go and see it, or see it again. And then you will see how this guy lived and the power of the machine he invented, in particular to decipher Enigma code. The definition of AI since Alan Turing, and this is his definition, changed slightly. It became the ability of an algorithm, not anymore of a machine, because now the machine was the same. The Turing machine, the universal machine, is the same, is exactly what we are using today. Since 1936, it's the same machine. The challenge was not anymore to construct a new machine, like Pascal did or Leibniz. The challenge was to come up with an algorithm that we would put on a machine that will indeed solve a problem that we thought was only for human. Are we together? So the challenge became devising an algorithm. Good. So AI is what is in prowess, is a prowess of an algorithm. Of course, if we say things this way, then doesn't look as sexy as the AI paradox. If I had entitled this talk, The Paradox of Algorithms, maybe half of the room will not be here. So AI is an attraction, very important. In my books, I don't call them algorithms, I call them AI, to make sure that somebody buys the books. So then history accelerated. But what I want to share with you here is the importance of finding the right algorithm. So addition, multiplication, what have you. And then interestingly, and this is very important to understand in order to maybe have a clue about the future, there were several steps where we thought algorithms will never be able to do this. And then we got contradicted. For example, the chess. At some point we said the Soviets and the Americans were hardcore enemies after the Second World War, unlike today. They were very enemies. They were really competing. And they were competing in the Olympic Games about who runs fast, but they were also competing about who is smarter. And the chess was the measure of who is smart. And the people, the Soviets, were much better than the Americans because they had chess schools in every neighborhood. They were very good. There were only one American who could compete, Bobby Fischer. So the Americans said, okay, we cannot beat these guys à la régulière. We need to do something else. Let's use our computers. So they asked, so when you get stuck, what do? You call professors in computer science. So they asked, this was a joke, sorry. They asked professors from CMU, Carnegie Mellon University, and asked them to work with IBM and come up with an algorithm who could beat the world champion in chess. There is a very, very interesting series on Arte and France Culture about this episode. It's really amazing because some people said, no way. This is something we cannot do. And then people start thinking, oh, what is chess? It's like a tree. You do this, if the queen goes this and then the king goes there, maybe you should do this. They asked Bobby Fischer to help them. They devised the algorithm, and the algorithm did beat Kasparov in 1997. And people said, addition is not AI. Multiplication is not AI. That's too simple. Chess is AI. Okay? Now, nobody will call my chess software on my smartphone AI. But the definition changed. Why? Because at some point we thought that was not possible for a human, and then we solved it, and then we say it's AI. L'effet de surprise est passé. We move to something else. Are we together? The algorithm was a tree-oriented algorithm. And then people say, no, but that's too easy, right? That's too easy. By the way, under brackets, something very important. The machine that could beat Kasparov was a huge machine, very, very expensive. And people would say, oh, if we want to do better chess algorithm, we need to build bigger machines. But then other engineers came and said, no, we just need smarter algorithms. And then we could do better chess systems with much smaller computers. Does it ring a bell? ChatGPT, DeepSeek, we always start by saying we need huge machines. And then some smart engineers come and say, nah, let's just think more carefully. We can do it with much, much cheaper. And that's what happened in those days. So a few years later, we said, well, chess is easy. What is challenging is natural language, because it has a lot of ambiguities. And that's something machines will never able to do. Again, some professors and some engineers got together and developed an algorithm to play Jeopardy. Jeopardy is question pour un champion in the US. So you have a question with the natural language. You need to disambiguate the question and then go find the solution and give it to the audience. A machine could beat the US champion of Jeopardy, and people said, oh, that's AI. The technology was not the same as chess, but still we call that AI. Why? Because it was, again, surprise. Things went on. We said at some point, well, but what would be really, really, really impossible, what is impossible is to do art. Art is something only human can do, because emotions, because love, because hate, all this is really human. And art is the representation of our emotions. So machines were never able to do that. Again, some kids, really kids, young students from Amsterdam, maybe they got bored by their parents taking them every weekend to see all the museums of Amsterdam, decided to take the challenge up. So they said, okay, Rembrandt, what is Rembrandt? What is Rembrandt's style? Okay, for a hardcore computer scientist, a painting is a matrix. Okay, painting is a matrix, and the pixels represent the painting, and the style of a painter is a pattern of organization of the pixels. So for example, the eye is like this with dark or gray colors. That's the style of Rembrandt. Maybe the mustache is like this. That's the style of another painter. So these guys, what they did is they wrote an algorithm where they feed that algorithm with tons of painting of Rembrandt. Basically, they enabled the algorithm to learn the style of Rembrandt. What does it mean to learn? To have all those matrices stored in some database. Are we together? It was the first machine learning somehow step. But then what they did was amazing, was to say the algorithm that has learned all the matrices, we're going to ask it to toss a coin, au hasard, and then change slightly the eye, change slightly the mustache, change slightly this and that, and produce something new. Okay? So the algorithm started producing new stuff based on what it has seen. That was the first step in what we call today Gen AI. What is it? You start with something you know, you change few things, you generate something that looks like what exists, but it's different. They generated 100 Rembrandt-like painting. They took them to the MoMA in New York. They asked the expert, is this Rembrandt? And the expert were unanimous. Absolutely. That was really amazing, because this would mean, again, we can do this for everything. Picasso, for everything, etc. Of course, they got into some troubles with the painting industry, but they managed to show that we could do it. And that was machine learning, generative AI. If you want to remember these notions, just remember about learning the matrices that represent Rembrandt's style and then generating new ones. Is that simple enough? Ça va? Good. The Go game was also something very interesting, another step. The reason you heard about the Go game, I guess, the Go game was interesting because people said this game is a different beast, because the rules are you need to surround the stone of your adversary with your own stones. That's the game. The rules are simple, much simpler than the chess. But that means that the number of possibilities is much higher. When the rules are simple, numbers of possibilities are higher. The number of possibilities for the Go game are more than the number of atoms in the universe. So you cannot apply the same techniques as for Rembrandt or as for the chess. You need intuition. Intuition is something that only human could have, right? But again, some engineers from DeepMind said, no, maybe we can represent intuition in the computer. What is intuition? Intuition is the fact that you try some experiences, and if it works, you remember it, and then maybe you apply it almost the same or slightly differently. So that's what they did. They devised an algorithm that learned alone. So the chess algorithm did not learn alone. It learned with Bobby Fischer and with other experts. The Go algorithm was just playing against itself. Okay, several processors, they play against itself. If processor 1 wins the party, it remembers the strategy. Okay, so it plays it again. Nobody was intervening, no Go experts. After 24 hours, the resulting algorithm, based on what we call sometimes reinforcement learning, you learn, you win, oh, that's good, you remember, that's intuition. It won against the champion of Go, Lee Sedol. And for the Chinese, for example, for whom the Go game was amazing, that was the turning point in their investment strategy. 2017, they said, wow, we are impressed. How could a British company beat our world champion? We need to do something. And that was really impressive. And we called that AI. By the way, the Nobel, in this Go game, we could observe that some of the plays, certains coups, used by the game has never been used ever in the history of humanity. So this was something, just like the Rembrandt algorithm produced new Rembrandt painting, here some of the strategies had never ever been used. And now people started talking about AI that discovered new strategies. So remember, what does that mean? It tries several strategies. One of them works. It combines it with something else. And then it became scary because we say, oh, this is something very new. The Nobel Prize, I don't know whether it was physical chemistry this year, is exactly the same, by the same company. And they also discovered new ways of putting genes together. So this ability to discover, it's actually something concrete that started in 2016. AI is the ability of an algorithm to solve a problem that we thought was reserved for human. But that's just a definition that is interesting, l'effet de surprise, etc. What is crucial is the fact that we have algorithms and machines. Okay? More precisely, algorithms. Are we together? I'm going to go slightly quickly for the rest. Why now? What happens now? There was an alignement des astres. So the planets got aligned, and more specifically, 3 planets got aligned. Algorithms were able to network, learn and create. This is something I said, but I will just come back and repeat. There were these 3, I would say, the first one is more like a technological revolution. The other 2 are more mathematical revolutions. These 3 revolutions together enabled us to have the power of algorithms today. Clearly, the fact that we could put machines together at large scale, internet, or at a small scale, multiprocessor computers, enabled us to somehow multiply by whatever factor we wanted the power, performance and storage abilities of machines. That everybody knows, right? But something else interesting. When we connect machines, we make them more performant, we make them more reliable, because if one machines fail, the other continues, etc. But there is also some notion of emerging intelligence. Let me just give you a quick challenge. Assume we managed to invite Kasparov. Actually, he visited EPFL. And Karpov, Karpov was the first champion, and then Kasparov was the second. We invite them here. And Kasparov is on this floor, and Karpov is on the other floor. And then we ask you, we organize a game with Kasparov and Karpov, and if you lose against both, you will be hanged. You will be sent to spend the weekend with Trump. What do you do? How do you manage not to lose against both? You might be clueless in chess like me. What do you do? Sinon, pas de café. Comment? You make them play against each other. What does that mean? Karpov is sitting here. Kasparov. You ask Kasparov. Allez, Royal, vas-y. Kasparov starts, plays. And you say, wait a minute. You go down. You play against Karpov, but Kasparov just plays against you. You wait for Karpov to play, and you keep doing that. I'm completely clueless in chess, but I'm not going to lose against both. If one of them wins, I will win the other one. Are we together? This is some kind of emerging intelligence. People like to talk about emerging intelligence. What I did is simply playing one against the other, and I managed to appear again as a good chess player. So when you put machines together, you have more power, more performance, but you also have this ability to make some kinds of emerging intelligence. The second important aspect I said was that algorithms started to learn. If you think of the addition operation, it's the same since the 8th century. It didn't change. You can prove it. Algorithm proved it in 8th century that it works. And today we don't ask ourselves whether it works. We know it works. Multiplication is the same. But when you have algorithms that start learning from what they have seen, from Go plays or from Rembrandt or whatever, the algorithms become like a changing entity. And you cannot prove them anymore because their behavior changed based on the data they learned on. So this is good and bad. It's very good because it enables you to generate Rembrandt, and this is powerful. But it's also dangerous, and that's the paradox I will come back to. Okay? The third part is the ability to generate. Okay? I gave you an example with the play, but it's important to understand what's happening in those kinds of algorithms. Google, which dominated the world for many years, and nobody could expect Google to be threatened by another company, was based on the dream of reproducing the Alexandria library. Okay, so the designers of Google, the inventors, Sergey Brin and Larry Page, their dream was, let's reproduce Alexandria library. Let's put together all the books that we have on Earth, and more precisely, the links on web pages, and find a way to find them, circulate among those books. Okay, that was the dream. But when you ask something to Google, it gives you an actual link to a real information. Are we together? Now, what we have seen with ChatGPT is something completely different. Think of it as the goal is not to reproduce the Alexandria library, but to reproduce what's happening. Do you know where this place is? In Marrakesh, there is this place called Jam Fna. It's protected by UNESCO because it didn't change for several centuries. And there is an interesting phenomenon there. There are people sitting, they tell stories. You can come and you give them just few ideas. You say, oh, can you tell me a story about this? You give them few hints. And they start cooking up a story. So they're not giving you a book or an actual information. They're just inventing something. And what they invent is pretty good. It looks very reasonable. But 99% of the time, it's completely wrong. So this is ChatGPT. Okay? It tells you what you have seen in some format. Okay? Exactly like WhatsApp complements your messages. Hello, how are you? Comment ça? It adds va because it has seen that most of the time va comes after comment ça. It's exactly ChatGPT. Except that WhatsApp looks at all the conversation we had. ChatGPT looks at the internet. So it just goes and finds something and gives it to you. And the relation to truth is very relative. They don't care whether that is true or not. Okay, but that's, again, this is an interesting, from the one hand, it's great because it's creation, but on the other hand, it's very dangerous. So, 3 factors made AI or algorithms so powerful. The ability to network, the fact that the algorithms learn from the data, they improve, and that they can generate. But at the same time, and this is the paradox, they make them very vulnerable. And I think the big challenge for us, and maybe for you if you want to work on this field, is how to turn circus animals into domestic pets. Let me explain what I mean. The chess game was like a circus animal. You bring it on TV, you put it on an RT series, and then it beats Kasparov, but that's a circus animal, okay? People watch it on TV. The Go game is the same, okay? So these are these animaux de cirque. Now the challenge is, can we turn those algorithms, those systems, into pets that will obey and which we can trust? And that's not easy at all, because the very reasons why those animals are becoming so powerful is precisely the reasons why we cannot trust them. Are we together? Because they do create, but the way they create is simply au pif. They do learn, but they learn from data that can be not only bad, but poisoned. Somebody could put some data that is bad precisely with the aim of producing some bad output. So people say that 80% of new AI projects fail. But that's some numbers I have seen, which sound reasonable. So what investors do is they try to diversify, and then they invest in you, and maybe 3 out of 4 will basically go and bankrupt. But that's fine. As long as one of you succeeds, they're very happy. But you need to realize that that's what's happening. And one of the reasons why is that happening is, again, because the data might be poisonous, because the strategies they're adopting might be completely flaky. But that doesn't mean that we should not try. What I'm simply saying is that we should know that. So the AI paradox, and this was the AI is indeed faster. Again, when I say AI, remember algorithms. But just remember that to sell my books, I use AI. I don't say, but it's the same. Algorithms are today faster, and they make, on average, fewer mistakes than humans. Okay? But at the same time, they make faster and bigger mistakes. And this is, in my opinion, the biggest challenge as scientists, engineers, whatever, especially those like you working in cybersecurity or security in general, need to face. So what now? What can we do? Of course, I come from academia, so the first thing we need to do is really understand what's going on behind these beasts. And believe me, it's not rocket science. Of course, if you look at the interfaces, they look extremely complicated. Oh, you use tokens to have ChatGPT, or you use gradient descent, or you use this and that. But if you think about it more carefully, it's not that difficult. And it's important to understand in order to make them more secure, or use them, or deploy them, or whatever. So master the principle. Of course, we need to try. I see in many cases some big companies, sometimes I work with some companies in Switzerland, and what they do is they create an AI center. So they hire data scientists, and then they have a nice walls, typically painted with orange. For some reason, orange seems to be the color of digitalization. And they buy computers, and we have an AI center. What are you going to do in it? We don't know yet. And that's completely crazy, because you end up with the functionarization of something very important. Instead of starting with actual teams working on a given project and trying to use some of the techniques like recommendation systems or whatever, and then try. And that's, in my opinion, much more valuable than creating an AI center and then telling people, okay, why don't you use the AI center? One thing that many people seem to ignore is the following. I hear many times people saying, oh, but AI is becoming so powerful. Why doesn't AI verify or certify the AI system? It looks reasonable at first glance. You can say, why can't we build algorithms to check whether what the other algorithm has said is true or false? Then we would have certifiable AI. Interestingly, in 1936, in the same paper where Alan Turing invented the universal machine, he first proved that his machine will not be able to solve all possible problems, And he gave as an example, it will never be able to verify itself. Okay, that we know that from 1936. So when journalists or whatever talk sometimes in the media, they say, but AI will be able to do everything. I thought, no. We know that from 1936, there is an infinite number of problems that cannot do. In particular, algorithms cannot reason about algorithms. Okay, so that we know, which is good news for us, because it means, oh, we still have some value as a human being. Because if it could do everything, then we are in big trouble. But the act of verifying, certifying, etc., with current technology, which is the Turing machine, we know we cannot do it. So maybe some other engineer will come and build a new kind of computing theory, but for the theory we have, we know it's impossible. So there needs to be somebody to say, this looks good, or this is bad, and certify, and then go to jail if things go wrong. Because a machine is not going to go to jail. I mean, they don't care. You can put it in jail, but doesn't care. So, just give you an intuition before I finish. I told you three things. One of them is AI is algorithms when they surprise us. Second, algorithm is powerful because we can put machines together, we can generate, learn, etc. And the third thing I said is that makes it vulnerable. And then I said, we need you, or they need you, or they need us. We need to do something. Now the question is, what is that we can do? Is this something concrete we can do to certify algorithms or certify AI, etc.? I'll just give you one example of something I and my group have been working on for the last maybe 12 years. It starts with this. Again, forget the fact that it's a theorem. It's like AI. It's just there to impress. What are we talking about? Today, if 99% of the AI systems, what they do is they gather data from different sources and they average them. Okay? So they use techniques called gradient descent, whatever, to optimize a function, and then they average the results of the optimization and they try again. So averaging is very, very important in AI systems today. But let's think about it. Assume we want to ask or build a model to predict the temperature that we have. Okay? In the learning phase in Lausanne, in Vaud, in Canton de Vaud. And we measure we use sensors to measure the temperature. So today, I think it was 3 degrees in Aubonne, so maybe it was 4 here. And then another sensor tells us it's 5, and another one tells us it's 2. If we average, that is very fine. But now assume the sensor is wrong, or somebody is manipulating the sensor and putting it's minus 2000. If you average, you're completely screwed. And if you don't realize, the machines don't care, you do it, you average, you say, oh, I have a new model. But the model is because of one single data. You can have 1 million sensors. If one of them gives you minus 2000, averaging will screw up your entire model. Now, another challenge to you, what should you do instead of averaging? Merci. Median. Amazing. Mathematic discovery, we can use median. If we use median, then we will somehow ignore the minus 2000. And there is it looks very simple, but there is a huge literature of what we call robust aggregation, which consists in aggregating information or gradients from different sources and using a median kind of aggregation. And that reveals very robust. So those are the kinds of techniques that exist. Of course, it's simpler to say than implement, but these things exist. So I simply wanted to tell you that there is work in this area where you could build trustworthy models without trusting any single data source. So no single data source is trusted. And the fact that we use median enables us to do that. Of course, as long as the majority of data sources is correct. I'll just conclude by doing some advertisements. So some of my students and postdoc has just released a library called BizFL. So Biz is not for bisou. Biz is for Byzantine. Byzantine is a word that we use in our field to say malicious or bad. So Byzantine FL is federated learning, where you federate different information based on some Byzantine information. And for historical reason, Byzantine used to mean bad or poisonous or whatever. And if you want to know much more about this field, there is this book called Robust Machine Learning. In fact, what I said before is also based on a book called L'IA sur un transat. And that one you can easily read on a transat. It's the first part of what I said. This one, maybe you need to sit down. Transat might reveal challenging. It's exactly 57. I promise to stop at the hour so that you get your coffee. Merci beaucoup de votre attention. J'espère que c'était effectivement simple.
Thanks a lot for the presentation. Very, very enlightening. We probably do have time for a couple questions before we go down for the break. So if anybody has some questions, I'll bring the mic around.
Thank you for your presentation. And we from China. When I was a kid, I played Go. I know nowadays AlphaGo could defeat the human. My question is, I wonder if we could use the AI vulnerabilities or the force to deceive the AI, meanwhile following the Go rules. If we successfully, could we can defeat the AI? This means maybe our cybersecurity engineer could get the gold champions. So I wanted to know this method is possible or not.
I'm not sure I got entirely the question, but I would say everything is possible just to be on the safe side. But I'm not sure I got entirely the question.
The question is just like, the AlphaGo could defeat the human.
Yes.
That
Let's go step by step. AlphaGo defeated human. Yes.
Yes. And, the this human are not good at cybersecurity. Nowadays, we are good at cybersecurity. If we could also follow the Go rulers, we can do some vulnerabilities or the force to defeat the AI. And I think if cybersecurity humans could also defeat the AlphaGo.
Okay.
Yes, this is my question.
I'm not sure. Okay. As politician says, maybe this is not your question, but this is going to be my answer.
Okay. Thank you.
The usage of AI, to secure systems, I think is not easy. You probably remember the CrowdStrike event, and that was really AI in action. So it was AI looking at the internet traffic, making some analysis of the AI traffic and generating a new defense and sending the defenses to the Microsoft VIP machines, the business class Microsoft, and this screwed up the entire system. So it's very dangerous precisely because AI sometimes just says nonsense. I'm sorry, this might not be your question, but I'm simply saying AI to secure system is very dangerous. And Turing proved that this will never be 100% secure. So we need to do something human.
Okay, we probably have time for one more question. One over here.
Thank you for the presentation. Then I guess to like elaborate on this point, do you think we'll arrive at a point where AI makes less mistakes than humans and therefore it's less dangerous to entrust security to AI than to humans?
Yeah, this is really, I don't have an answer. The question is, will AI make fewer mistakes? The problem I see is that the progress of AI performance are directly related to the fact that we have a huge amount of data and a huge amount of resources and the ability to create more content. But that intrinsically means more vulnerabilities because the sources of data, we cannot control them. They're entered by human and sometimes they're entered by machines that themselves have learned from potentially bad data. So I really don't have a clear answer. We are working to try to make the number of mistakes smaller, but it's not clear to me that it's like driving faster with better cars and hoping to have less accident. It's not clear it's going to work. I don't know.
Excellent. Okay. So thanks again for the talk. I think we can give another round of applause.